Hey, geometry students. In this lesson, we are going to be taking a look at a topic that is a little bit difficult, and that is angles interior to a circle. Now, the only reason this is difficult is because it's hard to define the angles that are interior to a circle and understand exactly what we're talking about. And in fact, we're going to start off this lesson with a brand new word, and that word is the word subtend. We use the word subtend to describe a segment or an arc that has endpoints on the sides of an angle. Okay, so what do we mean by that? Well, here's an angle. We're going to be taking a look at angle EDF. So notice that D is the vertex of that angle. We would say that line segment EF subtends angle EDF because it has sides, its endpoints are on the sides of the angle, one on side DE and one on side DF. Now, segments are interesting. You can't have a segment with both endpoints on the same side of an angle unless it actually overlaps that side of the angle. But these, instead, if we look at the arcs, because arcs can subtend angles as well, arc ED is able to have both of its endpoints on the same segment of an angle, and that's fine. So we would say that arc ED subtends angle EDF. Why? Because it fits the definition. An arc subtends an angle if its endpoints lie on the sides of the angle. EF would subtend as well. Notice that its endpoints are on different sides, and FD subtends because its endpoints are both on the angle, even though they're on the same side. Now, here's the thing about subtending an angle that you need to know. When we do have an arc that subtends an angle, it can do it on the same side because arcs are curved. So this arc can actually go out and then curve back and reach back to the side of the angle. Segments unable to do that. So segments will always be on opposite legs of an angle, whereas an arc can subtend an angle on the same leg. And we're going to see that in the theorems coming up here. Theorem 64.1 states that the measure of an angle formed by a tangent and a chord is equal to half the measure of the arc that subtends it. Whoa! There's so much terminology here, we got to make sure we go through it. So first of all, we're talking about a line of tangency here. Notice that this line just barely kisses this circle at point B, okay? So this is a tangent line, but we're not talking about a diameter in a tangent line because remember, we could talk about the diameter, but we're not specifying the diameter. In the past, whenever we had a line of tangency and then a line in the circle, we were dealing with the diameter, which was always perpendicular to the line. Now we're dealing with a chord that makes a non-90 degree angle with the line. In fact, it makes one acute and one obtuse angle. Now, what can we do with this? Well, if we figure out the arc that subtends, how many degrees, the measure of the arc that subtends angle ABC, actually, that would be this angle here, or this arc here. If we figure out the measure of that arc, then what we can do is multiply it by 1/2, and that gives us the measure of the angle that it subtends. Okay, does that make sense? So ABC, if I want to find the measure of ABC, what I should do is find the measure of arc BEC. Okay, notice I named the arc with 3 letters because it's not a minor arc, it's a major arc, one of the big ones. If I find how many degrees of the circle this arc is, and then multiply it by 1/2, that gives me angle ABC. Same is true for angle DBC. If I figure out what the measure of this arc is, multiply it by 1/2, I'll get the measure of DBC. Now, there's another theorem. The measure of an angle formed by 2 chords intersecting in a circle is equal to the half of the sum of the intercepted arcs. Okay, let's take a look at what we're dealing with here. So if I want to know the measure of angle 1, I could figure out the measure of arc BC and the measure of arc AD, add them together, Okay, that's what the formula here shows. I add those together and then multiply by 1/2. That gives me the measure of angle 1. Wait a second, what about the angle opposite angle 1? Well, that is a vertical angle by the definition of vertical angles. So we know that that's actually going to have the exact same measure because it has the exact same set of intercepted arcs. Okay, for angle 2, we would use the arc of AB plus the arc of CD, add those together. So we measure that, add them, divide by 2, and now we have the measure of angle 2. Now, I've explained the theorems, but let's put them into practice because this is where they're going to actually start to make sense to you. All right, so the first thing we're going to need to do, find the measure of angle X in this figure. This figure is a little blurry. We have line M down here. It's a tangent line. X makes an angle with tangent line M. So X is an angle here for this chord, and we need to find the measure of angle X. But wait a second, we have an arc that subtends the angle 204 degrees on the same side as the angle we're looking for. So if I could find the measure of the arc that subtends this angle and divide it by 2, I should be able to figure out the measure of x. Well, 204 degrees is the measure of that arc. So if I divide that by 2, what do I get? 102 degrees. X should be 102 degrees. Let's see if that's right. Bingo. All right, letter B. Find the measure of arc MNO in the figure. Line N is tangent to the circle. So here I have a tangent line. MNO subtends my angle, and my angle measure is 92 degrees. So what is the measure of the arc? Well, the measure of the arc would have to be double the angle, right? Because whatever the measure of the angle is half the measure of the arc. So if I double 92, I should get the measure of M and O. Let's see, 92 times 2 is 184. Bingo, we got that one right. All right, next in letter D, we need to find the measure of angle X here. Ooh, this is one of those where we have lines that intersect in a circle, and we need to figure out the measure of one of the vertical angles inside the circle, angle X. To do that, I just simply add 115 and 59. That gives me 160, 174. And then I divide that by 2. 174 divided by 2, trying to do this in my head. It's going to be 87? 87 degrees. That's my guess here. I just 115 plus 59 divided by 2, 87 degrees. All right, and our last one, an artiste is drawing a design for a company logo that has a capital R inside a large circle as shown. Oh, that's fancy. She first draws a baseline at the top of R. That's going to be a tangent line. Let's see. And then the R is supposed to be at a 60-degree angle in relation to the baseline. So 60 degrees here with relation to that. What is the measure of arc M, which extends leftward from the top of R? So how many degrees would this be? Well, again, this arc subtends the angle. So that means that it's going to be double the measure of the angle because the angle has to be half the measure of the arc. So the measure of this arc should be 120 degrees. Let's see if we got that one right. There we go. All right, and that is how you work these sorts of problems involving angles subtended by an arc.